Introduction. Fire. This word always gives goosebumps to an automobile enthusiast, as for him the word fire resembles with the power. Of course it is true. Fire is the most important source of energy from the birth of the Mother Earth. In an engine, as we know, fire, which is produced by the spark plug, is the main source of energy that converts chemical energy into mechanical energy. This is the basic principle over which an engine works. Now let's race the horses of our mind and think, how does the combustion occurs in an engine with more than one cylinder? How does the firing of fuel be controlled in multi-cylinder engine? Let's just dig it out. Firing order of a multi-cylinder engine is the power delivering sequence of each cylinder, which is set by the designer such that the combustion of fuel in different cylinders occurs in a predefined order that can produce uninterrupted and maximum power output through the crankshaft of a multi-cylinder engine. The firing order is different for different engine configurations. For example, firing order of two-cylinder V-shape engine is different from the firing order of the four-cylinder inline engine. Why do we need firing order? As we all know, a four-stroke engine which we are using today works on an Otto cycle or a diesel cycle, in which a cycle that includes suction, compression, power and exhaust is completed in 4 strokes, or 4 movements of the reciprocating piston. And when it comes to the engine having more than one cylinder, the process becomes quite complex. So a predefined sequence of combustion, or firing of fuel, is required, as when it comes to more than one pistons, the load over the crankshaft increases as all the pistons are connected to the single crankshaft, and if the proper firing order is not provided to the engine, then there will be the chances of the crankshaft failure. The proper firing order of the engine provides maximum power, smooth running and high life to the engine, and also prevents the engine from unwanted vibrations. Out of the all 4 strokes required to complete an engine cycle, power stroke is the strongest and generates various stresses that can cause engine failure, like knocking. So it is essential for a multi-cylinder engine that the power strokes in any 2 adjacent cylinders must not occur at the same time, due to which an engine must have a predefined and proper firing order. The improper firing order can affect the engine and crankshaft balancing due to the generation of uncontrolled stresses, due to which harsh running, unwanted sound and unwanted vibration can be obtained from the engine, which can suddenly break any component of the engine and is quite dangerous for the operator or the people nearby. Improper firing order of an engine directly affects the fuel economy of the engine due to the improper combustion caused by the improper firing order. Operator faces engine starting problem because of the disturbed spark timing caused by the improper firing order of an engine. For the proper understanding of the firing order of an engine, let's us take few examples of the different multi-cylinder engine used in today's automobile cars. Inline 2-cylinder engine of a Tata Nano. In Tata Nano, 2-cylinder inline engine is used, even being the more than one-cylinder engine. Firing order is not so complex, as it is quite obvious that when cylinder 1 will get firing, or the spark plug ignition, then the cylinder 2 will be a compression stroke, and the order of the firing will be 1-2. Inline 4-cylinder engine of a Maruti Suzuki Swift. In cars like Swift having 4 cylinders placed in a straight line, the firing order is configured as 1-3-4-2, which means all the cylinders will have firing, or the spark plug ignition, according to the 1-3-4-2 sequence. It is found that in a 4-cylinder engine a complete firing order gives 720 degrees of the crankshaft rotation, which means each power stroke by the individual piston gives 180 degree of rotation to the crankshaft. All the 4 cylinders in inline 4-cylinder engine are mounted over 4 pins of the crankshaft placed in every 180 degree of the crankshaft. For the smooth working of a 4-cylinder engine, it is required that each cylinder will have different stroke at any instant. For example, at any instant in an inline 4-cylinder engine, usually it is seen that when cylinder 1 is having power stroke, then cylinder 4 is usually seen to be suction stroke. Cylinder 2 and cylinder 3 are usually seen to be at exhaust and compression stroke respectively. V-shaped 2-cylinder engine of a Harley Davidson Iron 833 bike. In Harley Davidson Iron 833, Two-cylinder engine placed in V-shape is used in which same firing order as inline two-cylinder engine mentioned above is used, that is 1-2. V-shape six-cylinder engine of Honda Accord in the high-end cars line Honda Accord and Audi 8. High-power engine having multiple cylinders are used as in Honda Accord. Six-cylinder engine placed in V-shape is used in which a proper and effective firing order is required. The firing order in Honda Accord is configured as 1-5-3-6-2-4. Firing order 1-5-3-6-2-4 means the crank pins having piston mounted are arranged in every 60 degree of the crankshaft. As the power impulse is generated in every 720 degree rotation of the crankshaft, which means that power stroke in V6 engine is obtained in every 120 degree rotation of the crankshaft. Flat six-cylinder engine used in Porsche 911 GT3 and some cars like Porsche 911 GT3. Six cylinders placed in horizontal plane having opposite direction, that is cylinder 1, 2, 3 are placed in left side, and cylinder 4, 5, 6 are arranged in right side, are used. Same as the V6 engine, all the pistons are mounted over 6 crank pins placed in every 60 degree of the crankshaft. The firing order of this type of engine is configured as 1-4-5-2-3-6, which means that the firing or spark ignition will occur at every 120 degree of the crankshaft rotation. If you liked this information, then don't forget to like, subscribe, and share.